changing one plate to another, and so on. Right?
So when we say thread is like compared to a process, we mean that the memory required by the thread is less. But is it the looking processing power also required by the thread is less, or should it be same to the process?
No, it's the same.
It's the same.
So processing, you just, as much of processing is available, the threads can do. But threads are more within the family of the process. Right? So what happens is they can share the variables. For example, the browser, there are a lot of things which are common on the top, the menu and so on, downloads and whatever happening. So they can share across each other very easily. If there is a process, sharing between process is very hard. Actually, that I would recommend that you go through that. You can create a pipe and so on. You can send a message. So it takes a long time to share between processes. Between threads, it's very good. So this is what the threads are. So let's take a break of 10 minutes and then we'll talk about the memory and so on. But now, within the categories, if you have any questions, come back with the questions. I will move on. Whatever I don't question you, whatever you want to know, I should tell you this. So if you have any questions on these or even on these topics, think of the questions and come back with the questions. Can anybody tell me what are different types of memories in your computer? Yeah, so that is part of the saving of Right? There's no packaging this. What we do is they do a that is what the ultra netbook or ultra book or the MP3 players, iPod, iPhone, all these things, they have something called the flash memory. So you will have nowadays a lot of devices come with flash, and then at the end you have disk. So finally it's disk drive which rotates and so on. How do you rate disk? Nobody knows. Of course there is memory is one, how many gigabytes, terabytes, but what is the other thing?
Access, RAID 1.
RPM, right? Somebody say RPM, right? So how fast everything is going? Just like the car. Rotations per minute. How many rotations can you make in 1 minute? Like, so more the rotations, the faster is it is. And again, there are different types of this inside. We will not go into detail. So basically, we have so many memories. We have, let's say, one processor. Next, we move to a case where we have multiple processors. But for now, let's just have one processor. Now, do you know what processor is looking at the memory? What is its picture? So you have the picture of these different memories, right? What is processor thinking? Right, so there is address. So it will address everything by address location. So when I do a processor, these are address bits and these are data. There are some address pins from the processors, there are some data pins. Everything is in terms of address. So what will be the address of the processor? How many addresses can the processor have? Processor, let's say we have a 32-bit processor. 64-bit nowadays, or 64-bit processor. Right? So it knows that 0 to 2 raised to 64 minus 1. Right? So these are the address locations a processor can generate and access. So this is the view of memory for the processor. It doesn't know there is RAM, it doesn't know there is hard disk, it doesn't know there is flash. And why is it so? So this is an engineering question. Processor does not know what type of memory it has got. What will be the reason? Is it a good thing or a bad thing? It must be a good thing because this is what the processor does, right? This is a good thing. Why? This is only example required. Sorry? Yeah, but what would be? This is a simple reason, but it's an engineering reason. The still has to know it. If you need to fix this thing, what happens is, see, you don't know where your processor will land up. Right? Intel is manufacturing all these processors. It's not a mathematical question actually. It's not a system question, it's just an engineering question. Somebody will put in an ultra notebook, somebody will put in an ATM machine, somebody will put in an iPod or phone. So you don't really know where this processing is going to come at the end, which part. And so you can't assume that this will be the memory. So you make processor as much generic as possible by just saying, you send me an address and somebody will give you data. Now who will give you data? Processor sends out address bits 100000 something. It is expecting data. So which is the entity that will push the data? It's the memory chip. It's the RAM that you put in or whatever you put in, it has to. Right? Now so think about this. There are so many memory, we don't know which memory should give back the results. And that's where the OS comes in. Right? So this is where the OS is sitting. It is sitting in between the processor and the memory. The processor is here, memory is here. OS knows what is the memory, how much is the RAM, how much is the USB disk, 4 gigabytes, 8, 1 GB, how much is the disk, 250 GB, 640 GB, 1 terabytes, how much is the RAM, ROM. OS knows everything. When you install, when you take that live CD or put the CD inside your disk drive and install the operating system, OS first finds out what is the memory available from BIOS. bias knows it. Then it now creates the whole map within itself where different memory is located. Okay? Now when the processor asks for a memory location, OS will tap it. OS will actually tap onto these wires and see what is the address. It knows the address, it knows where it has kept the data. Right? We go to that memory chip, get the data and give it to the processor. This way processor is completely ignorant. The whole memory is a black box for processor. It just sends out some bits, gets the data. Now OS, as you see now, has to do so many things when the address comes up. And that is what the whole job of memory management for OS is. Now how will OS store data among all of these? Can you tell me what data which OS should put under this? What data on the flash, what data on the RAM, what is on the RAM, cache and so on and so on. Even registers are stored by the OS. Right? OS tells the processor store this variable inside your register. So how will it select? What is the strategy? Right. So what will OS do? Just like shortest job first. OS first of all will try to keep everything in the disk. One reason is it's non-volatile, so it will not, even if you switch off the power, the data is already there. That's why we keep it. We keep all of these things, the precious things, empty. The reason I am calling this precious is because speed is high. And now let's ignore the cost part of it. So we are done with the cost. These are all costs, so it will keep them empty as much as possible. And some address get reference again and again and again and again. It knows that every time I cannot go to the disk and get this data. And it's slow. It slows down the performance. So it will try to move it up the hierarchy. Right? First it comes to the flash. Just forget the ROM for now. It will go to the RAM. Even in the RAM it is getting reference again and again. It will go to the cache. And so on. Even if in there it is not, it will go to the register. It will be very fast. This is the fastest thing. Right? So the OS is keeping a track of all the memory accesses. And then if a memory is being accessed again and again by way of frequency, you can put it at a higher location. So is this part clear? So the two concepts. One concept is OS is the whole magician to control the memory. The processor doesn't do anything about this. It just thinks I have these many bytes or these many words. It curious to something. The actual machine may not even have this much data. And that will come later. Right? So it's just not worried about how much memory your computer has, nothing. The OS is now doing all those things. So it's like keeping the family together. Right? Okay. So now there is something called a dynamic and static. What is a dynamic memory allocation and what is static? The thing that I described, was it dynamic or static? The strategy I described about memory is dynamic. Next, because the data is actually moving up. Right? So that is dynamic memory. A static would be nobody uses static. But just for a theory, academic purpose, static is when you allocate it, you store the variable, and that's it. You forget it. You don't move it. Okay? So what is the challenge of dynamic memory? Static is easy. Processor will always say 0, 1, 1, 1, 1, 1. You get the data. Next time it says 0, 1, 1, 1. You get the data. Right? The data is still there. In dynamic, what will happen is one time you say 0, 1, 1, 1. Data is here. Next time you say 0, 1, 1, 1. The data could be here. Third time the data could be here. What will the OS do? For a dynamic memory. Right. So what is the data structure you need? The hash table or let's say this table. Let's not go to the hash table. You just need a map or a table saying 0, 1, 1, 1 is at this location. Okay? When the OS moves that data to another location, it will modify this pointer accordingly. table that we use. Is this concept clear? Now I will keep on adding complexity to this concept, right? This is a very simple table, right? Another thing you can do is instead of table, just another way of doing it. You have something on the base address and an offset. Right? So you take for one process, you give him a base address. This is let's say my RAM. And this is my base address. Right? So this is just to make it efficient. I don't need to share every pointer at every location. I just for every process I store one base address and one offset address. Right? So the process P0 accesses some location, I go to the base address of P0 where I kept it, find out the offset and give it back to me. I don't have to really store the entire absolute pointer to that location. So this is what the array is, what you use in array. Right? When you access an array, there is a base address and then everything is just an index which is an offset 0, 1, 2 all the way down. So this is what the OS does. I think you can have a table like this or a base and offset.
How does the base and offset help in comparison to direct mapping?
So you basically store on these locations. If you store a global pointer, the value is there. This is 64 bits. But in terms of base and offset, for all these values, there is just one base. Okay? So you just combine all of these, let's say 32 bits, and just have one 32 bit address. And then everything is just offset. So basically, you save on the memory.
The access time will be slightly.
Yes, so that is always a trade-off. Okay? What will happen is when you try to optimize something, but so the offset will be, you have to do more calculation, right? So the calculation is take the base, add offset, and then reference to that, which doesn't consume much time. Addition is very easy. Memory time access is always up. You need everything 64 bits, it's very slow. So is this concept clear of memory management? What is paging? I did not explain anything about paging and segmentation. Explain is wondering. Because whenever you read about memory management, it's always paging and segmentation. So what is paging and what is segmentation? Let's just talk about paging first. Right? Right. So, one analogy that I always give is of a book. Right? We have a book. It's not one page we can write. It's not one single page. You can write the whole book in just one page. The page will be really long like this. Right? What we do is we divide the whole book into equal size pages. It's 100 pages, 400 pages. Why do you do that? Right? First of all, the size becomes easy. Right? Same thing happens here. Whenever you want to look at a memory location, you don't want to look at the entire. So the big this page, maybe even this big as well. Right? And I have to search something on the text. But other way, if I can just divide everything and make it a nice book file, I can say, look at page number 100. You can jump to that location directly. Right? So this is what the OS does. It takes the whole memory, divides into very nice pages, and shows you one thing at a time as a page. You can directly reference one page and read and write one page. So the reason for paging is because it becomes easy to handle in terms of memory. Okay? Now, how will you apply the concept of base and offset to your pages? Right. So you got points. So you can say page number 99, line number 3 from the top. So my base is that page number and offset is on that page where I want to look at. Right? So this is what paging is, basically. Okay, and then you can introduce the concept of dynamic paging, static paging and so on. Right? So what we do is, when you want to refer to a memory location on a page, you
internal fragmentation.
More than the fast. It is fast. At the end of the day, it makes everything faster. But how does it make it faster? So I'm just interested in one page, the year of the page. I remember 8 pages. But OS is taking the whole page and putting it.
It's faster to access the page than going to that exact line number and then putting it in. If you just put the complete page, it will be faster.
Faster? How will it become faster? It will take more time to read the whole page and put it. Right. What will happen is, the way we write programs, it's sequential, right? So you write instruction 1, instruction 2, instruction 3. So there is a very high probability that when you refer to line number n on this one, you will go to line n plus 1 and so on. Right? The for loops, if you see the while loops, and most of the time you will see everything out of that page itself. So OS says rather than you asking for another line again, let me just take the whole page and throw it inside the RAM. What will defeat this thing if we have a function call? Right? If we have a function call here that goes, it takes you to page number 100, right? Then you actually have defeated the OS. Right? OS will take the whole page, skip it. Next time you go to page number 100, that way of a function call, and it has to take the whole 100. Go to the 100 page and take it and put it. Right? So OS will need to be smarter. Which pages to load, which pages not to load. Any questions about paging now at this point? What is the concept here?
What is the advantage of using local language?
So the advantage is, let's say I have a for loop. And this for loop is on page 1 and line number 10. When I execute it, I will go to line number 11 and 12 and so on. Right? So OS says proactively, or it predicts that since you refer to line number 10, you will also go to line 11, 12, 13, 14. Because if you want to read one line, you probably read another line also. That's why it takes the whole. So this is paging. And this is how you can view a book. What is another way? Question.
What level of paging do you need to go?
What level of paging is the size?
And one level of paging, the page number, the line number, the level number. So everything can be paged, right? So the page number, the complete page is paged, that is one page. The next you can page the lines, basically your character.
So I'm not going into multiple levels of paging. Multiple levels of paging will be something like this library. Right? You have these racks. And you will put all the books of, let's say, OS into one rack. So that will make it multiple levels.
Yeah. So how do you decide what level do you need to go?
So you do multiple levels only when you have too much memory. And if you have just one book of 100 pages, you really don't do it. If you have millions of pages, you can't have it because even the big book will be like this. Right? So you have multiple levels. So let's not go there, multiple levels. So paging is one way. There is another way called segmentation. So what is the difference between paging and segmentation? Again, you can think of book analogy and tell me. I mean, those in the mobile company last might have heard this, but other people take a short glance. How would you think of segmentation? See, we use the same concept of book. Tell me what is segmentation. Anybody can answer the question. Also, right? And then you can immediately go there because we have an index in the book which says this chapter is this page number, right? Why do we do that? Because this is now a logical division. When I was dividing the book in terms of pages, I was not being logical. What I was doing is just look at the content and just chop, right? Now what I'm doing is these 10 pages will form one chapter. These 4.5 page will form one chapter because logically there is something common between these 10 pages and this 4.5 pages. This is how I can organize the whole book again, but a different way. And this is what you want to do in the code. Typically when the compiler compiles code, it's not concerned about how much is the data size, sorry, how much is the total size of the whole program. It wants to know how much is the code, how much is the stack, how much is the variable size, yield and so on. So you can divide all of these things into one segment. Typically you will have these 4 segments. So every process you can divide into 4 segments, right? Now next one is the question, what is the segmentation for? You must have seen this a lot, especially in the first year. You see more often and then you do this. So what is segmentation for? Right, so for example, in the code, let's say you jump to memory location, that is the second process. This is your process P0, this is P1. You try to look at the location here. Or within code also, you try to execute something in the data segment. Right? So this is the code segment. This is data segment. Right? If you instruction pointer jumps to somewhere within the data segment or to another process, you will get a segmentation form. That means you are trying to illegally access another segment, which is not allowed. The operating system, the processor is not aware of this. OS will jump in and terminate your program. So if this is illegal operation, you have to stop there. It will dump the whole snapshot of memory into some location. Why is it done? You know what that is called? What is the use of code now? Every day you are going to throw away this illegal process, why dump it somewhere? Debugging. Right? To help you debug why there was an illegal operation. If nobody gives you any data to debug, you can never understand and fix the program. Right? So it does it at some location where you can go, attach a debugger and something and find out why there was a problem, fix it. The concept of segmentation now is it's not standard size. P0 will have this much as 4 segment, even will have this much. So it will vary from process to process. One will have small, one will have big and so on. But then you can identify for every process these are the segments. And this is what the difference between paging and segmentation. Otherwise it's the same. How do you access a segment? How will you access a segment location? Use the same concept. Base and offset. Right? So if you know the base address, you just need an offset to find the segment. So it's the same base. Now, what to use? Segmentation or paging? What should the operating system use? We have 2 concepts in theory. What will be the reality? What will happen? Both. Right? So in reality, it's not either this or this. So the combination of these 2. How can we combine these 2? Segmentation. Because you want to logically understand process P0 is running, what is P1's data? Take all those segments, and within segments, now we will have these uniform size pages. Right? And you will bring these pages. So first is segmentation, and then inside this, now this is multiple levels. Inside one segment, you have pages. Because then you can just have uniform things and you can go through them. So any questions about segmentation and paging? This part 3. The only thing that is there now, how to replace pages. So if you look at your textbook, right, all the pages size, it's all uniform, right? If you are given a very standard thing, which is 2:64, it's easier to have pages of the same size. segmentation there could be a segment which is small enough. It's just for efficiency. Questions on this discussion from me? So one thing I want you to go later on is just like we talked about processes heavily. You can also have similar algorithms to find out which page to bring in, which page to throw. Right? Because page is coming from, so widely, page is coming from this to the RAM. What is the size? So this is big, RAM is very small. Right? So you cannot fit all the pages of the disk inside the RAM. You can only fit a subset of it. So which one to keep and which one to discard, that's where we need a algorithm. We can use the same thing, last recently used, first used, more often used, and so on. You can find out any algorithm and use that.
So what is the page fault?
So page, that's a good question. So I talked about segmentation fault. Similarly, there is a page fault. You don't see it in the program when you write it. You hear about it. What is the page fault?
Accessing a page which is not in the RAM.
This is not an illegal thing. Segmentation fault is something which is illegal. It's a bad thing. Page fault is not a bad thing. What page fault means is try to access the memory location and the page is not there in the RAM. Right? You go to the hard disk, bring that page, and then you resolve the page. So page fault is okay to happen every time. For the first time, you will be further. Next, this dynamic memory and static memory. This is very different. So what you haven't done, yes, maybe the next students probably have done is also compilers. Right? Students haven't done a course on compilers. So OS not only is doing all this business of memory, process, but it is also doing something that it notes your code. When you type program name, it actually does loading of this code inside the memory and executing this code. And so there are multiple things that compiler does, then the OS does. So what is linking? Anybody knows? So linking means whenever you make a function call and you haven't defined that function in that program, in somewhere else, in a header file, in a library file somewhere, you have to link it. Right? Let's say the example is printf. So you have to link it to the actual binary of printf. So that when you execute it, because nobody has seen a real printf, right? It's already there somewhere. You don't know where it is, but it is there. Anybody knows where the printf code is? Anybody knows? You call printf so many times. And you wondered where that code is sitting. This is just the header file. There is just the definition of it. Actually, where it is? In Linux. Something called header. Go inside that there is what is this is already take the code of printf, compile it and store it here. That's for you to use. It's already sitting there compiled. When you execute your program which calls printf, what should happen? So operating system knows that this is printf code, it is sitting in leave stdio because we have included this stdio.h. Dynamically, the word dynamic is very important. It knows this code of leave stdio and put it in the RAM. And this is the loading part. Load this code inside the RAM and you will execute it. And you again get back the control. What is the advantage of this? You don't have to compile it. You will need to compile it again. This part is not compilation again and again, but there is something more to that. advantage of doing this dynamic linking and dynamic loading? So what I'm defining is dynamic linking and loading. You know how many processes use printf, right? Almost every process uses printf. If you compile it every time and you load it every time, you will not do anything other than printf loading. Right? So that's why it's just compile once, load it once, so that every process that wants to printf can just use it. So this is what the advantage of dynamic loading is. And then you use it and then again you execute your own. Right? So all these lib modules inside, these are all dynamic. This is dynamic. What is static linking? Which we really don't use now. In these days of computer science, we don't use static linking. Right, so basically take the printf code, connect it with your code, compile it, load it beforehand. Everything is loaded beforehand, and you just run it. So nobody uses dynamic linking, some static linking and loading. So this is what dynamic, this is shared. Question for now is these days, how many processes do we have these days in your machine? You know? So what is your processor? Can somebody tell me? What is the processor we knowledge inside their computer? So when we buy a new PC, it says CPU this. What is your CPU in your machine? You see the specs of the computer, right? When you buy, it says processor this. Whatever, can you tell me what is written there in processor?
Overhead frequency.
There is clock speed. Yes. Size, what else?
Cores.
This is the number of architecture.
Cores, number of cores.
These days, I think this has become very important. This is what will define finally. This is not okay. But this will take the baseline for the computer. How many cores does it have? All the things that we discussed today was for one processor. Right? So if I want to change it and make it multi-core, what is a multi-core processor? Let's say I have a dual core processor. What does it mean?
There are two cores.
On the same time, right? These are the this is a dual core machine rather than E0 and E1. Right? And they talk to the cables. It's not like this. You take two processors, put them on the same card, the same silicon realistic, so they are very tightly integrated. Okay? And that makes it dual core, and quad core and so on. This quad core will have four of these entities. Now you see how complex things are become. Initially we were thinking of algorithms for multi-processes. So there is a concurrency control, this and that, and so it became very complex. And now actually I am into E0 and E1 and they are running something and they don't usually talk to each other much. So what will happen? There is a big problem of concurrency. So you need to basically rewrite the whole operating system. So that's why if you have seen, if you have a 32-bit machine and a single core operating system, you can't install it on a multi-core machine. You need to rewrite the whole operating system, and that's what all the companies did. When they move from a single core to multi-core, they have to rewrite the whole thing. And you can imagine the complexity of doing all these things. So what is the advantage of this architecture? Why are we going towards this? You have to rewrite the whole OS.
We couldn't increase the frequency to a limit of 3 GHz. So they
and other than that, so that is one thing you cannot. But other than if you see this architecture, you can send messages, receive messages. But this is very fast. They are on the same silicon die. So they can communicate very easily, even access each other's memory location possible. Right? So this is slightly better and this is faster than this one. And so that's why we went to multi-core. And then you see I3. What is I3, I5, I7? Anybody wonders what is it's not really core, it's the what you were saying, architecture. So Intel comes up with different architecture. So architecture is how you connect these processors and so on. Right? So these are different architectures. Basically it's some core, so you see the core. And the final thing is the cache size and the clock speed. Right? And all of these combined together will tell you something about the speed of the computer.
Since multiple cores are coming in the market, and we have this memory management of the system in place of the operating system, the kernel.
Right, so some things you can, so what happens is OS is completely software. You can take out something from the OS and put it there inside the processor. So for example, the memory management unit, MMU. Right, so you can basically OS thing. Memory management unit is something that OS usually does. So you can actually implement this in hardware for efficiency and put it inside the processor. So you can make this thing, by doing this, the operating system becomes faster. So this is different ways, cache, shadows, cores. The next one is VMs. Nowadays everybody talks about VMs. And you already know, since you know Java, you know what virtual machine is. So what is an advantage of VM in today's world?
So transporting the program from one machine, basically reusing the same kind of thing on multiple. I mean, you don't need to recompile the program again and transport it to a new computer.
So that is one Java thing, right? But I was talking more from the OS point of view. Why do you need this concept? So for your program, I understand what is OS is not about localization. Right? For OS, what is an advantage of having VM? So in fact, you can buy nowadays machine with just a virtual machinery. There is no operating system. It just comes with VM. Testing is one, but something more from the industry point of view. Why would they go for a solution of VMware, multiple that is one thing. What is happening today is machines are becoming very powerful. Right? So you have these blade servers or rack servers. These are very powerful. So for them to execute a Ubuntu or Debian machine, the operating system is not a big one. Right? And they will just last either 99% of the time. They have so much of processing power, they will just idle. So if I have to buy these blade machines or blade servers multiple times, and everybody is sitting 99% idle, I'm wasting my money. Right? So what will big companies like Google do? They will take this rack of blade server, put a VM, right? And then on top of that, they will put whichever operating system they want. They can, in the same server, they will put Windows, Mac, then Linux, different versions of Linux, so on. Right? So within one server, now you can have so many OS running at the same time. This reduces your cost. Basically, you reduce the resources. Another advantage is, if I want to use another machine for Linux, I just stop this virtual machine, just like I stop a DVD. I say pause, take back that program of Linux, just a file. You must have used virtual machine on your laptops also, right? You just stop it, take that file, put it in another machine, you say play, and it will learn from there. So you see, it's very easy. I don't have to switch off the whole server, take out one operating system and put it to another. And other operating systems are just running fine. I don't have to use machines. I can move from one location to another, and I can optimize my resources. This is an advantage of having VMs at the OS level. So now, do you know what happens inside the VMs? What is the difference between OS and a VM? One one thing is OS is running on top of VM, that's for sure. So what is VM doing now? What is the job? If you are the engineer, let's say you join a company who is creating virtual machines. What are you doing basically? Right, something similar. But let's see what is happening. There is Linux running, there is Windows running, right? Operating system thinks that it is in the full control of the processor. Right? Operating system is not aware that there is another operating system beside me which is also controlling the same processor. Right? Now the same thing that OS did for memory and processor, now the VM is doing for OS and the processor. So this is your VM, this is your processor, and this is your OS. One, OS 2. Right? So whenever OS 1 says set value of register 1 to 9, right, it's recorded by the VM. And when this OS says set the same value of register to 10, it's also recorded. Right? For the same register. And it will store the right value and the processor depending upon which OS has the control. In which process, this becomes more like a process. Depending upon which process is running, you will put the value. So now, VM is acting like an OS, and OS is acting like a process. So you understand there is a processor, there is OS, and there are processes. Right? Same thing is happening here. There is a processor. This is basically an OS, and this becomes P1 and P2. And you juggle between different operating systems. Because everything is now just a single process. You understand, right? So last two things. So file system I just ignore. There is nothing much technical or conceptual in the file system. It's just that how you allocate files varies from one operating system to another operating system, and each one has its own style. Right? It has some advantages and disadvantages. Basic thing file system has to do is create a file and safeguard it against crashing. For example, the disk, challenge on the disk. What is the challenge on the disk? On the CD, DVD, hard disk. What is the main challenge? So if I ask you to store something on the CD, will you be happy? No, why? It gets damaged very easily, right? Somebody just scratches it, it's off. Right? So that is the challenge. So you will lose the file. So the file system has to be careful and make sure that it creates enough redundancy in the file so that it can recover from the minor losses, not major. If you just crash your hard disk, just throw it down, then it breaks and then it's not possible. But for minor things, you want to safeguard against these glitches. So this is what basically the file system does. And the second thing is the security. Everything in the operating system is done through the concept of privileges, access privilege. Right? So every user will get some permissions for file. You can read it, you can write it, and you can execute it. Same thing for a group of users, and same thing for all the users. Everything will have these permissions. Whenever you try to access a file, OS comes in. It sees what are your permissions and what are permissions possible for the file. So there's a match. If it's allowed, it will give you permission access given. If it doesn't match, it will say access denied. And all these operations of checking and modifying, these are kernel operations. So that you cannot do this. You cannot change permissions of the files that is not okay. Whenever you try to do that, first the kernel comes in. You can do all this business of privileges and then it will give you permission only if it is all passed by checks. Okay? So this is how the security is done. So I'm going to stop at this point. If you have any other topics or questions, you can ask me the questions now. Yes. and your RAM is 512 megabytes. What will happen is, there could be a scenario, it's not guaranteed to happen, but there could be a scenario where you are referring to the pages in succession order, right? You go to first page, second page, third page, fourth page, or even randomly, you are randomly visiting different pages. But you see, you don't have enough RAM to store all the pages. Right? You just have half of what you require. So in that case, what will happen is, you will get lots of page faults. So you have a page fault, you bring in a page, everything goes for file for some time, again you refer to the page, it's not there, it has to go to the disk bring it. So that is how it happens. So one way to detect this is what? The CPU utilization will go high. Why? Because OS is continuously jumping in to do this business, right? So usually what happens is the CPU utilization will be as low as possible. Not as low as possible, but something in between. Right? So that means OS is not doing all the business. See, OS is just like a housekeeper. You don't want somebody comes in and just housekeepers all over the place. Right? You want actual people, processes. The housekeeping business should be done behind the walls. If the CPU utilization goes up, that means OS is doing a lot of things. And that is how it's going to go. This is a way to detect, but it's not a guarantee. So you can't really be sure. You can just be, you can make a guess. Educated guess will be very accurate. It will be almost correct, 99% of the time. Oh, it will detect it. So what will happen is now how to solve this problem. You will detect most of the time correctly. How will you solve this problem? Try to make sure that the process gets most of the memory that is required. So typically the process requires, let's say, 256 megabytes of memory. Right? So you give that much of memory inside RAM to that process. If it is less than that, you will know that it will go to cache. You see, what you do is, you proactively take more pages and just store them. And if something like caching is happening, you terminate that process. Right? And wait for enough memory to get free. And they will be enough. If you don't have memory and it will be crashing, you can't do much about it. If you have far less space, which one is happening, they will be crashing. Typically, you can increase. So like we know the swap space in Linux. If you have installed Linux, there is something called the swap space. So it should be some function of your RAM. Ideally. If it is not that, I think it's twice of that. If it is not that, then your machine becomes really slow because it is almost crashing most of the time. Right? It's going and taking and taking and